So in this video today we're going to go over antiderivatives, which is one of the applications of derivatives. So we got this list of functions right here that we're going to use as examples. And what we're pretty much going to use is the power rule for derivatives, and it says the integral from x of n with respect to x. So pretty much it's the integral of x to the n dx. So it's pretty much means you're integrating with respect to x. All you have to do is, to find the antiderivative of this, all you have to do is go x to the n plus 1 all over n plus 1 plus c. But n cannot equal 1. That's when this equation is valid. What we're going to do is we're going to take the integral of this, or the antiderivative I should say, and then we're going to verify it by taking the derivative, and we should end up with the function that we had in the first place. So what we're going to do is f of x is equal to 12x, let me just put example. So we're going to say f of x is equal to 12x. So let's find the antiderivative. So integral from 12x. And then we're going to use some of our integral rules. And we're just going to put the 12x in front of the whole integral. So remember, you could think of this x having a 1 up here. So by this formula, we're going to put x to the 1 plus 1. Then we're just going to rewrite the 1 plus 1 all around here. So now our antiderivative is going to be 12x squared all over 2 plus c. And then we could furthermore just simplify that into 6x squared plus c. Simple enough. So then let's just take the derivative of this, 6x squared plus c. Now we know our power rule for derivatives, we just move the 2 in front, so that's going to equal 12x. And then if we take the derivative of any constant, well, that's just going to equal 0, so it's going to be 12x plus 0, which just equals 12x, which was the original function we had. So pretty much if you take the derivative of an antiderivative, you're just going to end up with the same thing. I know that sounds weird, but that's pretty much one of the great things about derivatives and integrals. Because if you don't know, an antiderivative is an indefinite integral, which means it doesn't have a domain pretty much, because a definite integral would have a domain that they would want you to integrate on. But we won't get into that today. We're just going to go over the general antiderivative or indefinite integral. So we just got done with our first example. Let's move on to our second one. So our second example says, just erase this real quick. F of x is equal to x squared plus 3x plus 2. Okay, well let's just write that in integral notation. So x squared plus 3x plus 2. But then, using our integral rules, we're just going to break it up in the integral of x squared plus the integral of 3x plus the integral of 2. And if we take the integral, well, so we can take the integral of x squared, so we're just going to use this. So x squared plus 1 is x cubed all over 2 plus 1 is just x cubed over 3. Plus x plus 1 is equal to 3x squared. And 1 plus 1 equals 2, so it's going to be 3x squared over 2. And then we're just pretty much going to add an x to that. Technically over 1. Which is going to equal 2x. And then we're going to put all plus c because it's an indefinite integral, because the only time you write the plus c is when you have an indefinite integral. So that's a big thing in this chapter. The only time you write plus c when you're doing antiderivatives or integration is when you have an indefinite integral. So now we have our antiderivative, which is x cubed over 3 plus 3x squared over 2 plus 2x plus c. So now if we take the derivative of this, x cubed over 3 plus 3x squared over 2 plus 2x plus c. So let's just take the derivative of it. So we know our power rule, we're just going to move the 3 up front. So this is going to equal 3x squared over 3 plus 6x squared over 2 plus 2x, actually plus 2 plus c. Well, it ain't going to be plus c because if we take the derivative of any constant, it's just going to be 0. So we can say plus 0. So this is going to equal to, these 3's cancel out. This, you can reduce that. So it's going to be x squared plus 3x squared plus 2. And we just wind up with our original function again. So if you take the derivative of an antiderivative, it's just going to equal your original function. And that's, like I said, one of the cool things in mathematics is this happens. Let's do a couple more examples. So we got f of x is equal to cosine x plus 3 sine x. So now we got trigonometric functions now. We're just going to use the same thing. So we're just going to go with the integral of cosine x plus 3 sine x. So now let's just break it up now. So the integral of cosine x plus 3, we're going to drag the 3 out in front, times sine of x. So we take the derivative, the antiderivative of cosine x. We're going to get sine of x plus 3 times negative cosine of x plus c, which is going to equal sine of x plus, we'll just change that to negative 3 times cosine of x plus c. And so that's our antiderivative of that. One second, let me just make sure I did that right.